What if I told you that one of the most fascinating blueprints for managing a complex AI system wasn't dreamed up in Silicon Valley last year, but in a socialist country 50 years ago? We're about to dive into a story that's part sci-fi, part political thriller. It's about an attempt to build a literal nervous system for an entire economy, and you know the lessons it holds for the future of AGI are just staggering. This is the incredible story of Project Cybersyn. Just look at this place. Seriously, it looks like the set from a lost Kubrick movie, right? But this wasn't science fiction. This was a real room in 1972 designed to manage an entire country's economy in near real time. And here's the kicker. They tried to do this decades before the internet was a thing. So the big question is, how on earth did they think this was even possible? And what kind of wild ideas were powering this dream?
To get our heads around the how, we've really got to start with the why. Because this wasn't just some tech for tech's sake project. Oh no, it was born out of a really unique and frankly chaotic political moment. Okay, picture this. It's 1970, and Salvador Allende has just been elected president of Chile. His big promise is something totally new, a peaceful, democratic road to socialism. A huge part of that plan was nationalizing the country's biggest industries, bringing them all under state control. The problem? That created a management nightmare of epic proportions. How do you coordinate hundreds of factories and companies, especially when you're in an economic crisis and facing massive pressure from the U.S.? They needed a new playbook, a radical one.
And so, you get this incredible pairing of minds. In one corner, you have Fernando Flores, this super sharp 28-year-old Chilean official who's basically been handed this impossible task of making the new economy actually function. And in the other corner, Stafford Beer, a flamboyant British genius, a total maverick who is a pioneer in a field called cybernetics. He thought big organizations weren't like machines at all, but more like living things. A socialist government hiring a jet-setting business consultant? I mean, talk about an unlikely duo, right?
So, Flores gets in touch with Beer, and the response is just electric. Beer immediately sees this as the opportunity of a lifetime. This wasn't just another paycheck for him. This was a chance to put his wildest theories to the test on a national scale. He wanted to build what he called a liberty machine, a system that could manage immense complexity without becoming a top-down authoritarian nightmare. For him, this was the dream gig.
So you're probably wondering, what was this radical theory that got Beer so fired up? Well, it goes way beyond just computers and wires. It was a whole new way of thinking about how things are organized, and it's called the viable system model. The key word here, the one you gotta remember, is cybernetics. It's basically the science of steering. You know, like how your thermostat works. It senses the temperature, sees if it's too hot or too cold, and then kicks the system on or off to get it just right. That's a feedback loop. Cybernetics is all about how those loops help complex systems, from animals to economies, stay alive and on track.
Now, here's a crucial point. Not all cybernetics is the same. The American flavor, which came out of things like building anti-aircraft guns, was very much about top-down command and control. But Beer's version was completely different. He wasn't looking at machines, he was looking at the human brain. He wasn't interested in rigid control, he was obsessed with how systems adapt and survive, how they self-regulate. His big question was, how can you let all the individual parts do their own thing while making sure the whole system hangs together?
And all that thinking led him to his masterpiece, the Viable System Model, or VSM. It's basically a blueprint for any system that wants to stay viable, that wants to survive. The easiest way to think about it is like a human body. System 1, those are your muscles, the factories actually making stuff. System 2 is the local nervous system that keeps the muscles from bumping into each other. System 3 is like the lower brain. It runs the day-to-day show. System 4 is the part that's looking ahead, scanning the horizon, planning for the future. And finally, you have System 5, the higher brain, which sets the overall purpose and makes the tough calls between what we need now and what we need then. Okay, so why does this 50-year-old model matter for AGI? Well, everything. The VSM is literally an architectural plan for building something that's resilient and can scale. It's a way to design a system that can handle mind-boggling complexity by balancing autonomy down at the bottom with a clear sense of direction at the top, all without a central bottleneck micromanaging every little thing. It's a recipe for an AI that won't just collapse under its own weight.
All right, enough theory. How in the world did this team in Chile actually try to build this thing? I mean, how do you take these super abstract ideas and turn them into a real, working, nervous system for an entire country's economy?
The project was officially called Cybersyn and had a few key components. There was Cybernet, which was the actual physical network of machines.
Cyberstride was the clever software that crunched the numbers. Chico was like an economic flight simulator to test out policies before they went live. You had the famous ops room, which was the human decision-making hub. And then there was this wild, ambitious idea called Cyberfolk, which was supposed to measure the happiness of the public in real time. Yeah, they were thinking big.
But they hit a huge wall almost immediately. Because of the U.S. embargo, they couldn't import new computers or technology. So, what did? They got creative. A team member literally stumbled upon a government warehouse that was filled with hundreds of old telex machines. They're kind of like typewriters that could send messages over phone lines. They'd been bought by the last government and then totally forgotten. This discovery, this Aladdin's cave, became the backbone of their futuristic network.
And the software they wrote, Cyberstride, was built on a really revolutionary idea for the time. Stafford Beer insisted this was not about creating a big brother state. The point was not to suck up every last piece of data to empower some central planner. No, the goal was the exact opposite: to use technology to give more autonomy, more freedom to the managers on the factory floor.
And this right here is the second massive takeaway for AGI. The system worked on a principle called management by exception. The software was designed to basically ignore all the data that was normal, that was within expected limits. It only sent an alert when something went wrong, when a number went outside its normal range. In our world of constant information overload, that is a profoundly important lesson. Filter out the noise. Focus only on the signals that actually matter.
Okay, now let's talk about the part everyone remembers, the room. Because honestly, this is the image that just burns itself into your brain. The ops room was designed from the ground up to be a totally new kind of place for making decisions. So why just 7 chairs? Not 6, not 8, 7. Well, it was all based on research by a psychologist named George Miller, who had this famous theory about the magical number 7. He argued that the human brain can only really juggle about 7 pieces of information at a time. The idea was to create a small, focused group that wasn't bogged down by stacks of paper, a group that could have a real conversation, a high-bandwidth discussion, looking at the same data. And the chairs themselves were part of the whole experience. They looked like they were ripped right out of Star Trek. Each one had this control panel in the armrest. The whole point was to create a feeling of immediate, powerful control. You weren't shuffling papers in some stuffy boardroom. You were in a cockpit, piloting the economy. It was an incredibly powerful illusion of effortless, high-tech command. But here's the crazy reality behind that illusion. There were no computer graphics back then, not like we have today. So every single chart, every graph you see on those screens, it was drawn by hand. A team of 4 women, all graphic designers, drew everything, which was then photographed and turned into a slide. This futuristic system was actually a brilliant socio-technical hack, a blend of high-concept theory and good old-fashioned low-tech human artistry. So picture the scene. You've got this wild, ambitious, half-finished system running on scavenged machines and hand-drawn slides. And then, in October 1972, bam, it gets thrown into the middle of a massive national crisis. It was time for its final exam. The project's make-or-break moment came when a massive trucker strike, backed by outside forces, tried to paralyze the entire country. The economy was grinding to a halt, and the Cybersyn team jumped into action. They used their telex network not for fancy analysis, but for raw, real-time coordination. Day and night, they were rerouting food and fuel, directing the few truckers who were still working. And you know what? It worked. For 26 days, this little network kept the country from completely collapsing. It was an unbelievable success. But the triumph was short-lived. Less than a year later, on September 11, 1973, a military coup violently overthrew the government. President Allende was killed, and Project Cybersyn was over. The soldiers stormed the ops room and smashed it to pieces. The dream was dead. So the hardware was destroyed, the team was forced into exile, and the project became this weird historical footnote. But here's the thing about Project Cybersyn. The physical stuff was never the most important part. You can smash chairs and computers, but you can't smash an idea. So let's just quickly recap the huge lessons we can pull from this for building AGI. First, the viable system model is still an incredible blueprint for building resilient, decentralized systems. Second, Cybersyn proved that you absolutely need real-time feedback to manage anything complex and dynamic. Third, that idea of filtering for exceptions is more critical now than ever. And finally, and this might be the biggest lesson of all, no technology exists in a vacuum. Cybersyn worked because of the people, the operators, the designers, the truckers. Its failure wasn't technical, it was social and political. And that leaves us with one heck of a question to chew on. Project Cybersyn was a human-run system, and it failed because of human politics. But imagine an AI built on these exact same principles. An AI using the VSM for its architecture, with today's real-time data as its senses, using exception filtering to stay focused. With all the technology we have now, could an AI succeed where we humans failed? And what would it even mean to build a system that's designed for adaptation and autonomy from the ground up instead of just top-down control? That's the ghost of Project Cybersyn, and it's a question we're all going to have to answer sooner than we think.